The shell method is something you can use instead of having to use horizontal rectangles to rotate around a vertical line. So here if we're going to rotate around the y-axis and we're using washers, then we would have to take two different integrals, this one here and then up there. So the shell method allows us to use still a vertical rectangle, and we're going to rotate it around the y-axis. So if we have this parabola and we're going to take a rectangle in the interval and then reflect it to the other side. And that will be this rectangle is rotated around, and if it rotates, it makes a cylinder. So maybe it's easier to see here. And we have a cylinder of radius x, and then the thickness of the shell is dx. And the height of the cylinder is top minus bottom. So in this case, the top of the region is x squared, and the bottom is y equals 0. So we have top minus bottom. And now let's put this into formulas. If we have the surface area of the cylinder, the surface area of the cylinder is going to be 2 pi r times h. 2 pi r is the circumference, and if we cut this cylinder and then unfolded it, it would be or unrolled it, it would be a rectangle, and the length of the rectangle would be the circumference. So if you have a cylinder and you cut it and unwrap it, it would unroll to be a rectangle. The distance around the cylinder is 2 pi r, and that means then the width of the rectangle is 2 pi r, and then we just have to go times height. So 2 pi r h. And then we're going to do, when we look at this graph, we're going to say that x, the number where we start between 1 and 2 is just going to be any x value. So the radius is just going to be x, from 0 to x. The height is going to be x squared minus 0. That's the area of the cylinder. Let's do volume of we're not doing the volume of the cylinder. We're going to do the volume of this shell. So this is a shell, and we'll just talk about, if we take the area of the cylinder multiplied by the thickness, then we're going to get the volume of the shell. Volume of the shell, and now we're going to do volume of the solid. And that just means add up all of these shells, and we're going to have from 1 to 2, we're going to add them up for x from 1 to 2. Then we have this. And if we simplify that, we get 15 pi over 2. So let's not write so much. I'll just say what the region is. The axis of rotation, x equals 4. And so if we wanted to graph this, we want to find its x-intercept. Divide by a negative. All right, so we know the graph is going to be at 1, 3, and we have parabola 1, 2, 3, 4. Here's the axis of rotation. So if we have a rectangle, it's going to reflect across that, and there is the shell. And let's zoom in on that. One, two, three, 4, and we have all right. We are choosing any x value between 1 and 3. Then we need to find the radius. So the radius is a horizontal distance, and we know this is 4, so the radius is right minus left, and that's just going to be 4 minus x. And then we have the height. The height of the cylinder is going to be top minus bottom, so that's just going to be the function minus 0 in this case. So let's look at this distance, or this distance is top minus bottom, and the top is, and the bottom is 0. Okay, let's find the area of a shell. The area of a shell is 2 pi RH. 2 pi times the radius times the height. The volume of a shell is the same thing times dx. And then we'll do the volume of solid, and that is integrating all of this from 1 to 3. And on the calculator we get that. All right, pause and try that one on your own. And we have to find the intersections because that's going to determine the interval that we integrate on. On the calculator, we graph the two functions and find the intersections. Don't round until you get to your final answer. So here we're going to keep more decimal places. So let's zoom in on the area that we want to All right, so we have a rectangle and we can reflect it over here. And in the interval, we'll choose an x value. And now we just have to talk about what is the radius. The radius is right minus left. X minus -5 is the radius. We need to have the height, which is top minus bottom. We see the top is the parabola, top, and the bottom is e to the x. So then we're ready to look at the area of a shell. The area of the shell is the circumference 2 pi r times h. The radius is x plus 5 and the height is that. Let's find the volume of a shell, and it's the same thing. Times dx, and then we'll do the volume of a solid, and that is the integral. We're going to integrate along the intersection. So we have negative 1.3159740.537274, and then we just have all of this. On the calculator, I got 42.206. All right, so it's always just going to come down to finding the radius and the height. The height is easy to do. We've done that a lot, and it's just going to be top minus bottom, whatever the region is, the top and the bottom. And then the radius is something new, and so that might be a little confusing. It'll require some practice. But if you draw this picture and you have the x is just going to be any point in the region, and then you look for the horizontal distance from the axis to the x, and it's going to be right minus left. We saw a previous one where the number was on the right. It doesn't matter. You're just going to go right minus left, and now we have the radius. All right, that'll do it.